Welcome. This is our 7th week of SCP-105, Life in the Universe. Very pleased to have you all here. This is our first investigation of the question about whether we can find life outside of the Earth, where we will consider actual places in our universe. From here on out, for the next few weeks at least, we'll be trying to look at actual places in our universe. And we'll start this week with our solar system. I want to thank all of those who've already posted on the discussion board for our class some facts and images about various solar system objects that you have been researching. And many of you have some very interesting ideas about the prospects of life on many of those different solar system objects. We'll be looking at a large range of things that have different kinds of names for what they are. For example, we live here on planet Earth, where there is certainly life. And we'll look at each of the planets. There are 8 of them in our solar system in turn. But the planets aren't the only thing in our solar system. Of course, there's the sun as well. And many planets have worlds that are orbiting around them, gravitationally bound to the planet. We call a satellite that orbits around a planet a moon. For example, our own moon, which has the name Moon, is a satellite of the Earth. And there will be worlds that are satellites of other planets as well that we will look at and think about whether life could live on those worlds. Just because we call something a moon doesn't mean that it can't have life. We'll also look at other objects that are orbiting the sun, which are not considered planets, mostly because they're too small. Some of these objects are called asteroids. Others are called Plutoids or Kuiper belt objects. Famously, Pluto is one of those sorts of objects and was downgraded from a status of being a planet to being a dwarf planet or a Plutoid or a Kuiper belt object in 2006. And there are still people upset about that. But basically, the reason for that we'll get into in our discussion is because it's much smaller than the other planets in our solar system. And finally, we'll also think about some of the most far-flung objects, which are comets, and think about what makes them different from the other objects we were discussing. I'm going to use some of the images that you have provided for our discussion. And hopefully, if you provided some of those images, you might recognize those yourself. So let's begin. So this is our week 7 discussion of life in the universe, where we ask ourselves the question, is there life in our solar system? The solar system, of course, is anything that is bound to the sun, including the sun itself, gravitationally. And it extends out quite a ways. The planets in the solar system extend out about 30 astronomical units away from the sun. That's 30 times further away from the sun than the Earth is. But there are objects further away than that. And the domination of the sun's gravity goes out almost an entire light year, which is much, much further than 30 astronomical units. We can think of the sun as exhibiting some sort of control over a bubble that's about a light year in radius. And beyond that or so, there are other stars which might dominate the gravitational field of those areas of space. We'll think about other stars in a few weeks, but for right now, let's begin our tour of our solar system, starting with the sun. This is a false color image of the sun. Of course, if you take a picture of the sun using visual light, you see basically a blank canvas, a ball of light that everyone is familiar with because we see it almost every day. But if I take a picture of the sun in a very narrow range of wavelengths, and in particular, if I look at high energy wavelengths, sometimes higher energy than what I can see with my eyes, I can make an image of the sun that highlights other features of it. And that's what's going on here. So we call this a false color image because that's not actually the color that we're looking at. It's been chosen to highlight features in the ultraviolet. And this image of the sun shows some pretty interesting activity happening. You can see some prominences, that's locations on the sun where it appears that hot material is leaving what we call the photosphere, the boundary between the sun and outside space. And you can even see an eruption that's happening. We call such things coronal mass ejections, or CMEs. This activity dominates a lot of the particles that are swirling around this part of the solar system. And in fact, here on Earth, we should be aware that there's a lot of these particles streaming out of the sun called the solar wind. And these high energy particles could be very dangerous for living things. We're protected from being exposed to these particles by our own magnetic field here on the Earth. It might be interesting to think about what would happen if there was no magnetic field protecting us. Would life be able to survive? Now, one question you might have is, are there life forms on the sun or very close to it? From what we understand for what life needs, the biochemical makeup of life that we've been interested in, it's way too energetic, way too hot, and not enough of the material in the form of molecules is available at the sun. So life as we know it, of course, is not there. There could be forms of life that we don't know, that we don't understand. But that would require a completely different sort of investigation, something that we haven't even begun to look at yet. So for the most part, scientists say we don't think there's life in the sun. Now, if you wanted to think more closely about that, you might be able to. But as there hasn't been a lot of work that's been done, I think most scientists would want to look very carefully at anybody who claimed otherwise. Let's move away from the sun and go to the first planet that orbits it, the closest one to the sun, called Mercury. This again is a false color image. It's highlighting certain features on this planet. And it was not more than 10 years ago that we sent a probe to really map the planet well. And that's the image that you're seeing here from the probe Messenger. One of the surprising things about Mercury is that it, although being close to the sun would make it very hot, and indeed when it is facing the sun, it's very, very hot, there's another side of every planet that faces away. And when you're on that side of the planet that faces away from the sun, in the shadow of Mercury, it can get quite cold. In fact, much, much colder than it gets here on Earth. And the reason for that is Mercury doesn't have an atmosphere. And atmospheres have an effect of insulating a planet so it doesn't cool off completely, getting down to very close to absolute zero, or the temperature of space. So it's interesting that Mercury has both very hot spots in its daytime side and very cold spots on its nighttime side. That means that if I were to take a measurement of the temperature from the hottest point to the coldest point, there would be some point along there where the temperature would be just right for life to be surviving, at least for temperatures we see here on Earth. Those temperatures exist on Mercury. The problem is they don't exist in any one spot for a long time. As day turns to night and the temperatures change, we end up in a situation where either you bake or you freeze. But one thing that's interesting to consider is that Mercury is orbiting the sun in the same way that it's rotating the sun. That is, that its axis of rotation is basically 90 degrees straight up and down from its path around the sun. And that means at the poles, North and South Pole of Mercury, there are locations which don't get very much direct sunlight, almost ever. Because the planet Mercury never tilts towards or away from the sun, it's straight up and down. Up near the poles, there are areas that just get glancing sunlight all the time. When there are craters up near the pole of Mercury, the bottom of those craters may never see any sunlight ever. And that would make those locations very, very cold. So even though we're quite close to the sun, there are locations on Mercury that stay very, very cold. Much, much colder than the coldest temperatures we have here on Earth. But one of the interesting things about cold temperatures is that it can trap certain molecules, such as water. And in fact, it looks like that has happened on Mercury, that there is frozen water trapped at the poles, probably underground. That's intriguing because although there is water on Mercury and it's in a frozen form, and we might say that that shouldn't allow for life, we know that water is very important for life. And the fact that there is water on Mercury, even though it's in an ice form, might make us think a little bit more carefully about whether it could possibly be a situation where a tiny microorganism might be able to survive somewhere deep inside the surface, maybe in a border between where it gets very hot and very cold, eking out some liquid water just on the edge of what is possible. People think that this is a hypothesis one could have, and it can't be dismissed completely. I think if we were talking about this planet maybe 20 years ago, no one at that time knew that Mercury had water, and it would have been dismissed as a completely dry planet. It doesn't have an atmosphere, so that makes us think perhaps it's not a good place for life. But nevertheless, it's something to consider now that we know it has some water. You might want to return to it and think about it more carefully. The next planet we're going to investigate is Venus, the second planet from the sun. It's the hottest planet in our solar system, even though it's further away than Mercury, because it has a very thick atmosphere that keeps the temperature off the surface very, very high, close to 700 Kelvin, 900 Kelvin, depending on what temperature and exactly where you are. Those thick layers of the atmosphere dominate as clouds that are seen in this image. This is actually another false color image to highlight where the clouds are. But those clouds make it so that the entire planet is always enveloped. You can't see the surface unless you use special equipment like radar to penetrate the clouds. Now, although the surface of Venus is very hot, we don't see any water. The cloud layers of Venus will get cold because the outer region of space is very cold. The surface is hot. There has to be a temperature in between that's just right. And that layer happens to be at a pressure that's very similar to Earth's pressure. The clouds on Venus, unfortunately, are sulfuric acid, which we think is very dangerous for life. But we know that there are some acidophiles here on Earth that can withstand more acidic environments than other environments, the environments that we would normally need in order to survive. So is it possible that some life form might be able to survive in that harsh sulfuric acid cloud layer? I think people are not really sure or not very convinced that this can happen. But nevertheless, there was an observation that was made a few years ago, about a year and a half ago, in fact, that seemed to indicate that there was some interesting molecules in the atmosphere of Venus, in particular the molecule phosphine, phosphorus with 3 hydrogens attached to it, was discovered. Phosphine here on Earth is a byproduct of living things. Now, it seems like there might be some processes that could create phosphine without living things, but there was quite a lot of it in the observation. So they thought maybe there could be some microorganism creating it in the cloud layers of Venus. Unfortunately, further investigation seemed to indicate that that signal wasn't as strong as they thought it was, and perhaps they did not see phosphine in the abundance that they were saying. But it has made people interested in thinking about Venus as a potential abode for life. And we might consider it more ourselves as we design new space missions to go to different locations in our solar system. But let's now arrive at the one place we do know that has life. This is our own planet Earth. This is perhaps the most famous photograph of Earth ever taken. It was taken during the Apollo 8 space mission, which was a mission that left the Earth's orbit. It was the first mission to leave the Earth's orbit and turn around and look back, taking a picture of the planet. You can tell that there are living things on our planet because we can see, for example, the oxygen in our atmosphere. If you take a spectrum of the atmosphere and see what molecules and atoms are in it. And oxygen is created by living things, in particular plants here on Earth. You can also tell that there's a significant amount of liquid water. There's a thick enough atmosphere. There's a magnetic field. And we also have a companion, the moon. That companion provides for tides here on the Earth. But you might wonder yourself whether there could be living things on the moon. Similar to Mercury, people thought that that couldn't possibly be the case as few as maybe 15 years ago. But now we've discovered that similar to Mercury, the moon also has water beneath its surface near the poles, almost certainly in frozen form, but it's there nevertheless. Maybe there's some parallels we can draw with Mercury. In fact, people often compare the moon and Mercury. They're very similar sorts of worlds. In any case, the idea of traveling to the moon and starting a base is an interesting one people think about. Could human beings live on the moon? It is the one other location we've traveled to in our solar system as human beings. The moon has less surface gravity than the Earth, and it is particularly dry in most parts of it. But if you're near the poles, there are these deposits of frozen ice beneath the surface. Perhaps that could be a resource that would be used. Most people don't think we're going to find life on the moon, but it's still an intriguing idea, maybe one that should be investigated, especially because it's one of the easier places to investigate and send space probes to in our solar system. But let's move on to perhaps what people think might be the most likely candidate for a place where life could exist. This is Mars. Now, Mars is very cold, and it's also particularly dry. We haven't seen liquid water on the surface of Mars, although there have been some reports that there are indications of liquid water perhaps flowing just beneath the surface. And there might be places where liquid water forms rather quickly and evaporates immediately. There is ice on Mars in the form of water ice, as well as carbon dioxide ice. Most of the ice on Mars is the carbon dioxide, the dry ice, not necessarily best for living things. But there's enough water in the poles of Mars. You can actually see the ice caps on Mars. That it has made people curious as to whether there might be some reservoir where living things might survive. The idea is they'd probably be microorganisms of some sort. And in the past, Mars was much warmer than it is today. We may spend some time investigating all of the details of this. Mars is perhaps the most investigated world outside of the Earth, in part because people think it may be the most likely to have life or has had life in the past. So we'll keep in mind that Mars might be a great candidate for looking for life, but we'll continue to look at other places in the solar system since we have a lot of other options available to us. Now, Mars has two small moons. One's called Phobos, shown here, and you can actually see some reflection on Phobos that might indicate some ice that's in Phobos, perhaps even water ice. And the other moon is Deimos. Again, you can see the white reflections of this moon. This is two different views of the same moon here. These worlds are very, very small, a few kilometers, in fact, almost no gravity whatsoever. If there were to be life on either of these moons, it would have to be deep inside the interior somewhere. And it's almost certainly way too cold for there to be anything like life in Phobos and Deimos. But nevertheless, we do know about these worlds orbiting Mars. They are things to be interested in as we send more and more space missions to Mars and think about what the options and opportunities might be in exploring that world. As we move away from Mars, we enter the asteroid belt, and there are some worlds in the asteroid belt that are fairly large. The largest one, the largest asteroid, is named Ceres. Ceres is large enough to be bigger than the two moons of Mars, for example. It does appear to have some interesting ice beneath the surface, but it's very small. The surface gravity is incredibly weak, certainly no atmosphere. And I don't think many people have high hopes for there being living things on any asteroid, but we should be aware that these things are out there. And asteroids also are so abundant as they travel through the solar system, occasionally they collide. For example, with the Earth. Collisions of asteroids with the Earth formed a major part of the history of our planet. For example, causing the extinction of the dinosaurs and perhaps other extinction events on our planet as well. So asteroids are important for considering life in general. When we move beyond the main asteroid belt, we hit the biggest planet in our solar system, Jupiter. Jupiter is an absolute monster of a planet, much bigger than the Earth. You could fit many, many Earths inside of it. And in fact, it's such a huge planet that it doesn't really have a surface. The last four planets we considered, the terrestrial worlds, all have rocky surfaces. Now we're going to consider worlds that are called gas giants, because they have so much gaseous material surrounding them. It's very difficult to say where the atmosphere ends and something else begins. Without a surface, it's a little hard to imagine life existing the way it exists here on Earth. Could there be like these weird life forms that live throughout the planet, diving deep into the interior? One interesting thing to note is that the interior of Jupiter is quite warm. There's radioactive processes that keep it quite warm. But there's not very much water in that world, certainly no liquid water. And so any life form that were to be in the planet itself would be very, very different from life here on Earth. Maybe more possible than thinking about, I don't know, life in the sun, for example, but still particularly strange and weird. Something to think about perhaps, but not similar to life here on Earth. Jupiter has a number of moons that orbit it. We'll look at 4 of them and think about the possibilities for life of each 4. The moons of Jupiter interact with each other gravitationally in the same fashion that the moon and the Earth interact to cause tides. The tides on the Earth cause the oceans to rise and fall twice a day. And that's actually a depositing of energy into the oceans. It heats the oceans up ever so slightly. Well, the tides on the moons of Jupiter are much, much larger than the tides we experience due to the moon going around Earth. And these extremely large tidal effects actually heat up the interior of the moons. And in the case of this particular moon, the closest one to Jupiter, Io, will melt the interior, causing volcanoes. In fact, this moon is the most volcanically active world in our entire solar system. The fact that it's so warm might make you interested in thinking about life options and opportunities, but the volcanic interactions that happen seem to be particularly dangerous. In fact, a lot of the material that's erupting out of this moon, Io, surrounds Jupiter in a high energy particle environment we call a plasma torus. It destroys many of the spacecraft we send through the Jupiter system. Probably not great for life. But as you move to the next moon, Europa, this is a moon that people are very intrigued by. What you see here is basically a world covered in ice. And most of this ice is water ice. Now, it's very cold out here, but it's warm enough in the interiors due to the tidal heating that there is some liquid water that surrounds the entire world. And deep, kilometers beneath this ice, is an ocean of water that contains more water than all of the water on Earth. On this moon, there is a tremendous amount of the stuff we think is most important for life in its liquid form. Could there be living things in this ocean? This is something we would really like to find out. There are currently some missions proposed to go to Europa to try to answer this question. It would be a little bit difficult to answer. Getting beneath the surface of this ice is not the easiest thing to imagine doing. But it's such an intriguing question that I have no doubt we're going to continue to try to answer it by looking in various clever ways to see what might be beneath the surface of this world. Could there be life in the interior of Europa? I think this is one place where scientists think that this is a more likely scenario than many of the others we've been looking at. Perhaps only Mars is considered more likely than Europa. There are other moons of Jupiter that have oceans beneath the surface as well. Ganymede is the biggest moon in the solar system, much larger than our own moon, in fact, larger than the planet Mercury even. And it also has a subsurface ocean, not quite as large as Europa's, but certainly there. And also Callisto, the 4th moon of Jupiter that we're considering, has a subsurface ocean. If we don't find life in Europa, perhaps we'll find it in Ganymede or Callisto. There's a possibility. And it's certainly, these 2 moons are high on the list of priorities for people to investigate more carefully. But let's continue to move out into our solar system. We've considered the worlds around Jupiter. Now let's go to my favorite planet, which is Saturn. Saturn, I think, is a gorgeous planet, mostly because of its ring system. That ring system is a dynamically unstable amount of material that's orbiting the planet that can't form into any one object because the gravitational imbalance due to the planet itself prevents these rings from coalescing into one world. So you see these beautiful rings, and if you were to investigate each of them carefully, you would find that they were made out of mostly dust particles, most of the size of a grain of sand, some getting up to be about the size of houses. The fact that these rings exist like this fascinates people, and some people spend their whole lives studying this ring system. But we don't think that rings are necessarily going to be places for life. There's no atmosphere, certainly no liquid water per se. It's well outside of the protection of the planet. Like Jupiter, Saturn is also a gas giant that doesn't have a surface, has a fairly warm interior perhaps, but sort of similar to Jupiter, there's not a lot of hope held out for life being inside of Saturn. But there are two moons of Saturn which have held interest. In fact, there are many moons of Saturn which people think might hold similar sorts of subsurface oceans, such as the ones we were looking at in the moons around Jupiter. But there's one moon in particular that we know has a subsurface ocean, and there's another moon that is very intriguing. We'll start with this other moon that's intriguing, which is Titan. Titan is a very intriguing moon because it's the one location we've looked at that has an atmosphere that's about the same thickness as Earth's atmosphere. So Venus had a very thick atmosphere, much thicker than the Earth's. Mars had a very thin atmosphere. Titan is right there at about Earth's atmosphere. So for a long time, people thought, well, if it has the same atmospheric thickness as the Earth, could there be life on the surface of Titan? Well, it turns out that the temperature on Titan is a little too cold for liquid water. But it isn't too cold for liquid. In fact, there are liquids on the surface, and those dark areas you're seeing in this picture are the equivalent of lakes or oceans on this surface of this world, this moon of Saturn, Titan. But these oceans are not water. In fact, they are liquid hydrocarbons, ethane and methane, which is a very different sort of material. We have reason to believe that liquid is important for life. It transports chemicals from one place to another. It allows for kind of a happy medium in chemistry happening at a fairly rapid pace, but not too rapidly. In the context of water, we have one type of liquid that can dissolve what we call ionic materials, salts and things of that nature, polar material. Ethane and methane are nonpolar. That is, that they don't have electric charges imbalanced in the molecule. And so that generally means that they form liquids at lower temperatures, which is what we see here. And it also means that the chemistry is very different. There's not as much active chemistry that can happen in liquid ethane and methane, but there's not zero chemistry. So people think about whether it might be possible for there to be completely bizarre and new living things near the shores of these lakes and oceans on the surface of Titan. They would look completely different from the living things here on Earth. But could they exist there? It's possible. There are currently some planned space missions to Titan to investigate more carefully what's going on at that surface. There's been one lander that got to the surface of Titan. It didn't last very long. It was a planned short mission. Perhaps other landers will last longer on that surface and be able to investigate these questions more closely. So while the life that would be on Titan, if there are any life forms, would look very different than the life on Earth, it's not outside of the question that there could be something alive on that world. But a moon of Saturn that has people more intrigued than Titan is this much smaller moon called Enceladus. Like Europa, it's basically an ice-covered world. And like Europa, there's definitely a liquid ocean beneath. In fact, the liquid ocean beneath erupts from the surface and forms incredibly strong geysers that are strong enough to escape the gravitational pull of this small moon and make a tiny little ring around Saturn. One of the rings of Saturn is actually made by ice particles that are spewing out from the geysers of Enceladus. The fact that there is a liquid ocean beneath this surface, and we know for a fact there is because we see the water spewing out, means that some people are very interested in investigating this moon more carefully, especially because we have direct access to the ocean very easily. Europa, it turns out, also has some geysers, but they're not quite as strong as Enceladus. And those geysers on Enceladus, intriguingly, will take material from the inside and bring it to the outside. You can imagine flying a spacecraft through them to investigate what might be in that interior. If we found signs of life in those geysers, that would be amazing. But we need to keep going because we have other places to visit in our solar system. So we'll go now to the 7th planet in our solar system, Uranus. This is the planet that was just announced to be a high priority target for the next 10 years. It looks like NASA is going to have a mission to this planet to investigate it more carefully. I think this is a good idea. The last time anyone visited this planet was in 1986 with the Voyager 2 spacecraft. It didn't spend very much time there, only a few days, and then went off to its final destination, which was Neptune, which we'll get to in a bit. But Uranus is an interesting planet because it underwent a pretty massive collision at some point in the past. And that has caused it to have its axis tilted almost exactly on its side. So while other planets are close to spinning in the same direction they're moving around the sun, Uranus is spinning in the direction so that it is more or less having one pole face the sun for half the orbit and the other pole face the sun for the other half. That makes it a pretty interesting world. Now, it's also a gas giant, so it's similar to Jupiter and Saturn. We don't have much hope for life, but perhaps some of the moons of Uranus might have some subsurface oceans. Umbriel is an example of one of these, similar to what we saw in Saturn and in Jupiter. Well, we'll now move out to the 8th planet in our solar system, Neptune. This is the furthest one out. Was visited briefly in 1993, and then the Voyager spacecraft continued out to leave the solar system. Neptune is a world that's very similar to Uranus, except it has a moon that's much larger than any of the moons of Uranus. So that makes it an interesting world. This moon is Triton, and here's a picture that was taken, the only picture we have from a space probe, because only one has visited Neptune. What's interesting about this world is that it looks very similar to what we saw in Enceladus or Europa. It looks like it has an ice surface. And in fact, it even has the same sort of pockmarks that we saw on Io, like there are some eruptions happening, some volcanoes. But the world is way, way, way too cold to have volcanic eruptions like we see on planet Earth or on Io. This has to be something else going on. In fact, this world is made mostly out of nitrogen, solid nitrogen ice. That's a pretty exotic material. Here on Earth, it's very difficult to make solid nitrogen, but we do make liquid nitrogen. And under the right conditions, solid nitrogen will melt into liquid nitrogen, and that's what's actually happening here on Triton. There are eruptions happening of liquid nitrogen geysers, spewing out over the surface and forming an ice layer of nitrogen all across the world. So we have a liquid on Triton, but it's a liquid that here on Earth would kill any living thing. It's liquid nitrogen, but that's the only thing there. There's no other liquid available. If there are some chemistry that might happen in liquid nitrogen that might allow for life, perhaps it would develop here on this world, Triton, way out in the outer edges of the solar system. Something people have thought of anyway. Now, one question people might have is, why does Neptune have such a huge moon? Uranus has very small moons. Neptune has this giant one. Well, the answer is that Triton wasn't always a moon of Neptune. At one time, it was orbiting the sun in its own right. It was captured by the gravitational pull of Neptune. And there are other objects of similar size that are out beyond the orbit of Neptune, including perhaps the most famous one, which is Pluto. Pluto shares a lot of the same characteristics that Triton has. We don't see geysers on Pluto, but we definitely see ice fields. And Pluto has a very thin atmosphere, in fact. Pluto has intrigued lots and lots of people. And it was nice that we finally in 2014 got a mission to Pluto to visit it and take pictures and send back our first images. Up until then, we'd never gotten much better of a picture than a few points of light. Could there be life on Pluto? People think about this as a possibility in the same way they think of Triton. It would be very different than the life here on Earth. However, we do see some water ice on Pluto, which is perhaps in greater abundance than the water on Triton, for example. And so that might be intriguing. But as far as we can tell, no liquid water. Unfortunate. Maybe Pluto isn't a place for life, but it still has a place in a lot of people's hearts. One of the reasons Pluto isn't considered a planet anymore is because as you go out further, you find other objects that are the same size or sometimes even larger than Pluto. These are called the Kuiper Belt objects. And I'll show you a picture of one. This is a picture of Makemake. This is a enhanced picture. We have not visited it with a space probe, and it's so far away that our telescopes only give us a few little points of light, much the same way as Pluto. So we don't have much to go on to know what this particular world is like, or any of the other half dozen that have been discovered, Eris and Sedna and Quarwar, et cetera. Lots of interesting names for these Kuiper Belt objects, these Plutoids out at the edge of the solar system. But there's a lot of them. There's a huge number of them out there. And so it's an intriguing thing to try to discover them and figure out whether any of them have bizarre characteristics that we might be interested in investigating. Even further away than the Plutoids and the Kuiper Belt objects is a cloud of material that's called the Oort cloud. And every once in a while, some of this material is disrupted in its gravitational orbit around the sun and is sent in on a plunging orbit into the inner solar system. And as these far distant objects come into the inner solar system, the material that they're made out of, which is mostly ice, water ice, carbon dioxide ice, starts to heat up and eventually sublimate or gas away in amazing tails streaming out from these objects. We call such things comets. This is perhaps the most famous comet, Halley's Comet. Comes around every 76 years or so. The last time was in 1986. So you can do the math and try to decide whether you're going to be able to see it when it comes around again. These comets are generally way, way out, far away from the sun. And most of them will never get close to the sun, but the few that do come into the solar system in the interior bring material from the outside of the solar system into the interior. And a lot of that material is some of the CHNOPS we know to be very important for life. There are some proposals that comets might be the necessary ingredient for starting up the oceans on the Earth, or bringing some of the materials that we know are necessary for living things. I don't think that this is well agreed upon by everybody, that this is what is necessary for life to begin. But a lot of the same chemicals that are found in living things are also found in comets. Could comets have life themselves? Well, similar to Pluto and the other very cold worlds at the edge of the solar system, it seems that liquid is not very likely anywhere in comets. But nevertheless, they are intriguing things because they bring us all of the things we're interested in discovering. So that brings us to the end of our presentation here. I thank you very much for taking this journey with us. I hope you learned some things and have been thinking a bit about discovering life in the solar system. And we'll continue on next week to look for life elsewhere, maybe finding it on Mars, maybe finding it around other worlds.